Morning everyone. So in the last class we were discussing about the secondary steel making process, and some of you have taken seminars also regarding second steel making process. Some of people have taken AOD VOD process, and most of the topics were covered, it seems. And one more thing is important is that in secondary steel making process, the stainless steel making is very important, right? One of the special steel for a specific application is stainless steel, right? So that we have to know that how it is being made, what is the condition for the stainless steel making process, right? So before going to that, you need to know what is stainless steel, right? So stainless steel in the regular name, it is made for corrosion resistance, right? Element like chromium is added to the steel for better corrosion resistance. That is what your stainless steel. So stainless steel na staining agadu, okay? So neenga kelipattirpinga domestic applications ellame nama nariya use pannuvom, tumbler, plates, spoon, blades, right? So all these things we have different application for your stainless steel uses. It has a major application, right? So stainless steel is nothing but the composition contains a minimum of 10%. Generally it is 10 to 30% of chromium. Minimum it has 10% of chromium to maintain the corrosion resistance. If you have a lot of chromium in a steel, then it is called as stainless steel, right? So it may also contain some of the other alloying elements like nickel, moly, vanadium, titanium, etc., right? So the specific property element alloy add panni, we can make a different grades of stainless steel, right? So these are different types of stainless steel: austenitic stainless steel, ferritic stainless steel, martensitic stainless steel, right? So it has some difference between these types with their composition, right? Generally the composition varies like this: 18% chromium, 8% nickel. Generally chromium irukum, nickel irukum, carbon, it varies, right? So in the composition modification la nariya type of stainless steel vandu duplex type, precipitation on hardening steels, and these are the types of stainless steel, right? So over specific application, over type of austenitic stainless steel illa ferritic they will use for a specific application, right? So in the production of stainless steel, EAF is used for stainless steel making, right? So electric arc furnace main produce stainless steel produce they have used. They are consumed. They use the stainless steel scraps. Generally EAF scraps use steel form பண்ணுவாங்க, right? And particularly stainless steel involves the EAF process, and which it uses all the stainless steel scraps. So we have a shortage of high quality scraps. அதனால என்ன பண்ணனும்னா alternate charges மாதிரி ஏதாவது எடுக்கலாம்னு பார்த்து carbon steel scrap இந்த மாதிரி types of scraps எல்லாம் யூஸ் பண்ணி they have melted in EAF to produce stainless steel. அதில் தான் இது iron, chromium, ferroalloy இருக்குல்ல, ferroalloy யூஸ் பண்ணி கூட they have produced stainless steel. This is the recent thing they are using for stainless steel. This is the iron, chromium, ferrochrome is the important raw material for the production of stainless steel, right? Low carbon, medium carbon, high carbon. So these are the types of ferroalloys. Ferrochrome alloy they produce. இது வந்து manufacture பண்ணாங்க, production பண்ணுவாங்க. இது produce பண்ணி தான் உனக்கு வந்து ferrochrome வந்து கிடைக்கும். So we don't get naturally in nature of iron, chromium வந்து கிடைக்காது. We make it, right? So we ferroalloy, we make it, we manufacture it. So இதில் பார்த்தீங்கன்னா high carbon தான் யூஸ் பண்ணுறோம். ஏன்னா low carbon யூஸ் பண்ணுறதுக்கு it is very difficult to make low carbon ferroalloy chrome, right? So generally high carbon is used because of the cost of production of low carbon. Carbon low கம்மி பண்ணுறதுன்றது ஒரு பெரிய விஷயம் ஒரு ப்ராசஸில். ஓகேவா? ஸோ அயன், கார்பன், குரோமியம் இது இருக்கிற அந்த சிஸ்டம் இருக்கிற அந்த ஸ்டெயின்லெஸ் ஸ்டீலோட thermodynamics வந்து எப்படி இருக்குன்னு பார்க்கணும். ஸோ the condition for the stainless steel making we have to discuss it, right? So the thermodynamics of decarbonization அப்படின்னு வந்து நம்ம வந்து பார்க்க போகிறோம். ஏன்னா being stainless steel, the presence of chromium is actually helping in corrosion resistance, right? So the problem is that when we have carbon in that stainless steel during the process, இந்த ப்ராசஸ் முடிஞ்சப்பறம் ஸ்டெயின்லெஸ் ஸ்டீல் வந்து கார்பன் அதிகமாக இருந்துச்சுன்னா என்ன ஆகும்னா there is a tendency of formation of chromium carbide, right? So இந்த chromium carbide form ஆச்சுன்னா there is no individual element of chromium for corrosion resistance, right? corrosion வந்து resistance வந்து இருக்கணும்னா we should have enough amount of chromium. If it is formed, if the chromium forms any compound, then that chromium will not give its own property for corrosion resistance, right? So carbides are formed ஆகிடும் கார்பன் இருந்தால். அதனால் என்ன பண்ணணும்னா whenever we have carbon we have to remove the carbon for stainless steel making process, right? So chromium மட்டும் இருந்தால் தான் corrosion resistance கொடுக்கும். ஸோ இந்த chromium carbide formation தான் என்ன சொல்லுவாங்கன்னா the formation of sensitization சொல்லுவாங்க, right? Formation of chromium carbide precipitates during the process of the steel, right? So consider this reaction, chromium oxide plus carbon gives carbon monoxide plus chromium. சரியா? This is general stainless steel reaction in which we are going to consider here, right? So when you see this reaction, we can actually write the equilibrium constant value for this reaction. So other activity, chromium like Henry activity and steel, right? CO is a gas, partial pressure of CO, Henry activity of carbon, activity of this chromium oxide, right? So consider these all activity is equal to 1. Okay, and Henry activity of chromium is nothing but activity coefficient into weight percentage of that element. சரியா? F into weight percentage of that element. அதை நீங்கள் சப்ஸ்டியூட் பண்ணிங்கன்னா இந்த மாதிரி K is equal to FCR into WT weight percentage of CR power 3 into P power 4 CO. இந்த மாதிரி ஈக்குவேஷன் ஃபார்ம் பண்ணிடுவோம். ஸோ ஜஸ்ட் யூ write the activity of product by activity of reactants. So one of the researcher Hilty and Kavanagh has proposed an equation to find out the effect of this chromium and carbon in stainless steel process, right? So he developed a formula or equation, log percentage of chromium by percentage of carbon is equal to minus 13800 by T plus 8.76 minus 0.925 into log of partial pressure of carbon monoxide. This is one of the equation to find out the ratio of chromium to carbon. So we can find the value of this ratio, right? In the ratio வந்து என்ன சொல்லுது, when the ratio is increased, in the ratio வந்து increase ஆச்சுன்னா என்ன அர்த்தம், carbon is actually it is been removed. ஓகேவா? denominator கம்மியானதும் நமக்கு இந்த ratio வந்து increase ஆகும். So when we have this temperature and what are also variables, partial pressure of carbon monoxide, when knowing the value of temperature and partial pressure of carbon monoxide we can find out the ratio of this, right? So இந்த ratio increase ஆனால் நம்ம chromium வந்து உள்ளே இருக்கு, carbon remove ஆகுதுன்னு அர்த்தம். அதுதான் நமக்கு actually வேணும். We have to have the value of this ratio to be increased, right? This equation is for those stainless steel in which it doesn't have any nickel in it. Generally nickel add பண்ணுவாங்க, காமனாக இருக்கிற ஸ்டெயின்லெஸ் ஸ்டீலில் நிக்கல் இருக்குது, அதுக்கு ஒரு ஈக்குவேஷனும். In the presence of nickel we have again the same formula with the addition of this 4.21 weight percentage of nickel, right? So nickel increases the activity coefficient of carbon in the metal. Okay, one of the main advantage of having this nickel is that it gives extra strength also, and it has a combination property of strength and your corrosion resistance. That is why we add nickel, right? So in the equation of second and third equation, we have to find the effect of temperature and partial pressure of carbon. இதெல்லாம் மாறுச்சுன்னா என்ன ஆகும் இந்த ரேஷியோ நம்ம பார்க்கணும், right? So when we calculated for different temperatures, we keep the partial pressure of carbon monoxide. Partial pressure of carbon monoxide is fixed like 1 for all the temperature, 1873, 1973, 2073, 2173. So when the temperature is increasing, right? So you can see the value of this ratio for the iron chromium carbon and iron chromium carbon nickel, right? So the ratio pakana, it is increasing 25, 58, 128, 240. 1 atmospheric pressure of carbon monoxide ku partial pressure of carbon monoxide ku the temperature பார்க்கும்போது எல்லாமே increase ஆகுது. So in increasing temperature the ratio is increasing. Okay va? So decarbonization happens when we go for high temperature. Okay va? It may be of presence of nickel or absence of nickel. At higher temperature the value of carbon is decreasing. So only on varying temperature we have found that the value is increasing, but on varying the partial pressure we didn't know actually. So on keeping this variation in partial pressure of carbon monoxide, say 0.25. So here it is 1 atmospheric pressure, it is increasing. For the 0.25 it is the same for temperature. If you see 0.25 it is 89. For 1 atmosphere it is 25. On reducing this 0.25 it is 89. It is increasing. So we have to reduce the partial pressure of carbon monoxide also. So on reducing the partial pressure of carbon monoxide, the ratio is increasing. So high temperature and reduction of partial pressure favors the carbon removal, right? Thereby the increasing percentage of chromium is happening, right? So the carbon reaction is proceeded at higher temperature and lower partial pressure of carbon monoxide, right? So decreasing the partial pressure is to be done in the process. So how come we but the thing is that on the two condition, high temperature and low pressure of carbon monoxide. High temperature actually we generally we will not go high temperature in the stainless steel making or generally steel making process high temperature form or we can achieve the high temperature, but it will take time. So achieving the high temperature and achieving the partial pressure of carbon monoxide, both condition is very difficult. It requires time or it consumes a lot of time, right? So the temperature increase ஆகிறதுக்கு வந்து ஈஸியாக பண்ணிடலாம், பட் reducing the pressure is very difficult. அதனால் என்ன பண்ணாங்கன்னா they have gone for this vacuum condition. So on producing the stainless steel in a vacuum condition, we can bring down the partial pressure of carbon monoxide very easily even at lower temperature. So கம்மியான temperature we can remove that carbon monoxide. So partial pressure கம்மி பண்ணனா என்ன அர்த்தம், we are removing that carbon monoxide. So on having a vacuum condition of this process, stainless steel process, we can reduce the partial pressure of carbon monoxide very easily even at lower temperature. That is why we have different types of stainless steel making process, VOD, AOD and so on. Argon oxygen decarbonization, vacuum oxygen decarbonization. So AOD is the process, the first it started, and generally argon is supplied with oxygen to remove the carbon. That is what your argon oxygen decarbonization. So later they have found out that vacuum condition la vandu easy panna the removal of carbon monoxide panna appdi decide பண்ணும்போது then the VOD has come into the picture. So they have introduced in one more process, that is what your vacuum oxygen decarbonization, right? So these two processes are the important process for your stainless steel making. Even SAIL is actually having this AOD process, I think so, right? Salem SAIL plant and they are producing the stainless steel with this process, right? So this is all about your stainless steel making process. This is actually on the second unit solirukonu, but when we have this type of VOD AOD process, thermodynamic condition la inga sonna and correct ah irukonu anga sonna, okay. So you can have a good idea of the making of stainless steel with these thermodynamic aspects, right? So you should know the condition, high temperature and lower partial pressure of carbon monoxide, right? So next is your already sonna injection metallurgy. Injection metallurgy is our important study when we deal with the clean steel, right? So when we remove all the impurities, it is said to be a clean steel. Not only the impurities, we have to remove oxygen, gases, inclusions, everything, right? So this injection metallurgy has helped the secondary steel making process into different level, making the steel very clean, right? So we will mainly we add desulfurizing agent like powders, which are injected through a wires, calcium in the form of calcium carbide or calcium silicon, right? So in this way we have added calcium powders for the removal of sulfur main sulfur remove பண்றதுக்கு the calcium silicon wires, calcium carbide powders, calcium powders are added. And this calcium silicon wires are generally it helps in removal of some inclusions also, like alumina, right? So this calcium wire, it gives toughness and elongation. The property is achieved by lowering the value of sulfur, right? So Thyssen-Niederen system is a popular known injection system for your removal of the sulfur, which has been considered as the best process in the injection metallurgy, right? So later the inclusions sulfur impurities remove பண்ணிடுவோம். And one more thing is degassing techniques, right? So removal of gases is nothing but degassing. Important என்னென்ன gases இருக்கணும், ஆக்சிஜன், ஹைட்ரஜன் அண்ட் நைட்ரஜன், இந்த மூணே கேஸ் தான் இருக்கும் மேஜராக. வந்து வேறு எந்த கேஸஸ் இருக்க வாய்ப்பே இல்லை. நைட்ரஜன் நிறையா இருக்கும். ladle degassing, steam degassing, recirculation degassing, these are the types of degassing. So we have to remove all the oxygen, all the nitrogen and the hydrogen. So hydrogen, it has to be kept very low. It forms a hydrogen embrittlement. Hydrogen அதிகமாக இருந்துச்சுன்னா brittle ஆகும், சரியா? ஸோ அந்த மாதிரி cracks ஃபார்ம் ஆகும். ஆக்சிஜன் இருந்துச்சுன்னா ஆக்சிஜன் ஹோல்ஸ், ப்ளோ ஹோல்ஸு, பின் ஹோல்ஸ் எல்லாம் ஃபார்ம் ஆகும், ரைட்? Recirculation, steam, ladle degassing are the types of degassing techniques in which we use different techniques to remove the gases effectively, right? So that the topics are discussed பண்ணிருப்பீங்கன்னு நினைக்கிறேன். So in the next class we will discuss about the ladle gassing, steam gassing or recirculation degassing. Very brief-ஆக நம்ம பார்ப்போம், ரொம்ப டீட்டெயிலாக பார்க்க வேண்டாம், சும்மா ஒரு இன்ட்ரடக்ஷனாக பார்த்துட்டு we will have the difference between this degassing techniques and which will be the effective one. And recently company வந்து என்னென்னலாம் பண்ணிட்டு இருக்காங்க, ஸோ எப்படி பண்ணுறாங்க, என்ன, what is the procedure, what is the standard of procedure followed in these all degassing techniques பற்றி பார்ப்போம், right? So with this I will wind up the class and we will have a detailed discussion on degassing techniques in the next class, and after that we will go for the next unit, continuous casting of steel, right? So if you have any doubts you can ask me. Thank you.